And there is very interesting thing. Can you escape Earth's gravity? To leave Earth forever, an object must reach a special speed which is called escape velocity. For Earth, this speed is 11.2 km per second. That is about 40,000 km per hour. Could a car ever reach it? Comment below. This is Samir and you are watching My Scholars. In this video we shall learn what is escape velocity and how we can calculate escape velocity. Escape velocity is the minimum velocity required for an object to escape from a planet's gravitational field without coming back. We shall learn in this video the derivation of escape velocity. So let us start our video. Escape velocity is the minimum velocity required for a planet's gravitational field without coming back. It is again something went wrong. Escape velocity is the minimum velocity required by an object to escape from a planet's gravitational field without coming back. Here VE is equal to square root 2G capital M upon capital R, where V nu is escape velocity, G is the capital G is the gravitational constant, which is 6.67 into 10 to the power minus 11 Newton meter squared kg square. It is universal gravitational constant and M is the mass of the planet, whereas R is the radius of the planet. We shall see how we can derive the formula for escape velocity. We shall see derivation by using energy method. According to the law of conservation of energy, conservation of energy, that is initial energy is equal to final energy. Energy can neither be created nor be destroyed. So this way initial energy is equal to final energy. So we can say initial energy is EI, which is equal to kinetic energy plus potential energy. Final energy will be kinetic energy plus potential energy. And initial energy is equal to, formula for kinetic energy is equal to 1 upon 2 mv square, mass into velocity square, and that for potential energy is Gmm upon r. G is the universal gravitational constant, m is mass, and small m is the mass of the object, whereas capital M is the mass of Earth or planet. R is the radius of the Earth or planet, or the distance from the center of the Earth to the object. This way, final energy at infinity, when velocity will be 0, final energy at infinity, velocity will be 0, then velocity is 0. When velocity is 0, potential energy is 0. F is equal to 0. Applying conservation of energy, law of conservation of energy. EF is 0, therefore applying conservation of energy, 1 upon 2 mv square minus gmm upon r will be equal to 0. Transposing this to right hand side, we shall get 1 upon 2 mv square is equal to gmm upon r. Mass of the object m is negligible in comparison of the mass of the earth. So we are neglecting or leaving this m. This way, this will be 1 upon 2 mv square is equal to capital G into capital M upon r. Or we can say mv square is equal to m, also we are leaving here. We shall leave m here too. So this way V is equal to 2gm upon r, or V is equal to square root 2gm upon r. Now we shall find the escape velocity of the earth using this derived formula. Here we are going to find escape velocity for earth using formula v is equal to square root 2gm upon r, where g is the universal gravitational constant for earth. G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square, and mass of the earth is 6.4 into 10 to the power 24 kg, whereas the radius of the earth is 6.4 into 10 to the power 6 meter. This is not 6.4, this is 6 only. So mass of the earth is 6 into 10 to the power 24 kg, whereas radius of the earth is 6.4 into 10 to the power 6 meter. Now substituting these values into the formula. Substituting the values in the formula, 2 in place of 2 we shall write 2, in place of G we are writing 6.67 into 10 to the power minus 11, and in place of capital M we are writing 6 into 10 to the power 24, and in place of radius, that is 6.4 into 10 to the power 6, or this way velocity is equal to, on solving this all, 24, 11 and 6, that will be 17, 24 minus 17. One point on solving this all, we shall get 1.25 into 10 to the power 8 square root. On solving this further, taking square root of 1.25, v is equal to, and the square root of 10 power 8 is 10 power 4. This will be 11200 meter per second. And turning nearly equal to, and turning it into kilometer per hour, per second, that will be nearly equal to 11 point, dividing it by 1000, 11.2 kilometer per second. If we convert this into kilometer per hour, that is about 40,000 kilometer per hour. Could a car ever reach it? Comment below. Car can never reach this velocity, 40,000 kilometer per hour. This is our final answer, or final derivation value of escape velocity. Please like, subscribe and share our channel. Thank you for watching my scholars.